You have 100 feet of fencing to build with and are building the length of the pasture up against a barn. What is the maximum amount of area and what is the length and width needed to achieve this? So this is a classic optimization problem. So what they're saying is you have a length, you have a width, but then one of the sides, one of the long sides, one of the length sides you will not be using. So let's just say this side we ignore because it's up against a barn. Just imagine that's a barn. And so we're gonna have width here, and then this is length. So from this we need to construct a constraint. For this area, so our constraint will be, so we know that area is going to be, well, before we get to that, our constraint is going to be 2W, so 2 times width plus L, and then we know that we only have 100 feet of fencing, so we can only use 100 feet of fencing out here along this. So that width plus that length must be equal to 100. We can just ignore units for now because we do not need any fencing right here. And then from here we need to find the area, which we know the area for this is just going to be length times width. But before we can do that, we need to get we need to use our constraint to get common variables. So we'll just say, we'll use length in this case. Length equals 100 minus 2 times the width. And we plug this into our equation. So we'll have area equals 100 minus 2 times the width times by W. We distribute 100 width minus 2W squared. So now we have an equation for the area. So this is really the main thing that you're after in these types of problems, because this is just a classic maximum minimum problem. It's just word problem. And then from here, you just take the derivative. So derivative of this, 100W, that's just going to be 100 minus 4 times the width. And then you want to set that equal to 0. Because from finding maximum and minimum, you know that it's either going to be a maximum or a minimum when that change is 0. So this change here is 0. Because you know the derivative is just the instantaneous rate of change, which is just a tangent line. So when that equals 0, you know you're either at a point like this on the graph, which would be a peak, or you'd be down here in a trough, which would be a valley. And you can sometimes you need to do some interpreting, but most of the time it's pretty straightforward. So here we know, we just solve for this. So 4W, this is just going to be equal to -4 width equals -100, width equals 25, and then we plug this back into our constraint. So 2 times 25 plus L, that's going to mean 2 times 25 plus L equals 100. So just from this looking at it, you can tell length equals 50. So length equals 50 and width equals 25. And then the maximum amount of area is just going to be, you just plug in those two numbers, and it's just going to be 50 times 25. Okay, for the next problem,